Hello friend, I am Ghanshyam and I am here with taking another problem related to measurement of resistance. So previously we have discussed about the measurement of resistance problem, that is the finding of uh, galvanometer current and unknown resistance to balance the circuit. So let's discuss about the problem of measurement of resistance, another problem. So here the forearm of western bridge are as follows: FB is equal to 100 ohm is given, BC is equal to 1000 ohm is given, CD is equal to CD is equal to 4000 ohm and DA is equal to 400 ohm. A galvanometer with internal resistance of 100 ohm and a sensitivity of 10 millimeter per microampere is connected between the A and C, point A and C, while a battery of 4 voltage is connected between VD. Calculate the current through the galvanometer and the deflection of the resistance of arm DA is changed between from 400 ohm to 401 ohm. So what is he given? That is 401 ohm, and that is 100 ohm, that is 400 ohm, and that is the 100 ohm. And for voltage for voltage battery is given here in point P, D and B, and galvanometer ID. Galvanometer D is given between the point A and point C, and galvanometer internal resistance is 100 to 120 ohm. 120 ohm galvanometer internal resistance. So he is asking about while he is asking about let's see, while a battery of 4 volt DC is connected between BD, calculate the current through the galvanometer. So he is asking about calculating galvanometer current through the galvanometer and the deflection if the resistance that resistance connected the resistance connected between D point and A point, which is varying from 400 ohm to 401 ohm. So the resistance changed is 40 ohm to 401 ohm. Then galvanometer deflection is asking about galvanometer deflection and the galvanometer current. So it's like as the previous video, we have first calculated the Thevenin's voltage and Thevenin's resistance, then we have calculated the galvanometer current. Like that we have to proceed this problem. So first voltage across FB and voltage across CB. So voltage across FB, let's erase all those. Then voltage across FB is equal to total voltage, that is 4 voltage, into and the same whatever the voltage calculate, that voltage resistance in divided by total resistance, that is 400 plus 401, 100 plus 401, that is by calculating this 0.708 volt. And voltage across the C and B, that is total volt, that is voltage across the battery into 1000 ohm resistance divided by total resistance, that is 1000 plus 400 ohm. By calculating this we will get 0.8 volt, and hence voltage difference between the node A and C. So that is our Thevenin's voltage. Thevenin's voltage is equal to voltage difference between the point A and C. So VTH is equal to VSC, that is equal to VA minus VC, is equal to VAB minus VCV, so that our VSC will be formed. So I'll put all the value of the VAB and VCV in this equation, then we will get 0.798 minus 0.8 is equal to minus 0.002 volt, that is Thevenin's voltage across the galvanometer. And then we have to find the Thevenin's resistance or equivalent resistance across the A and C point. So next slide. Here, like that previous problem, we have also calculated this. So point here, let's see it. So point here, the voltage is short circuit, and the current across the galvanometer will be open circuited to calculate the equivalent resistance. That is open circuit and that is short circuit. And by short circuiting, the D point and B point, D and B point are connected at a one point, and the resistance 401 and 100 ohm is parallel to each other, and 4000 and what is that? Let me erase. That is 1000 ohm and 4000 ohm are connected in parallel. So parallelly connected, and by series connection of those series connection, we will get in the left side that one 100 into 401 divided by 100 plus 401 plus 100 1000 into 4000 divided by 1000 plus 4000 is equal to, by calculating all this, we will get 4880.04 ohm. And current through the galvanometer is VTH divided by, this is a formula, and by seeing this figure, we will also easily identify how to calculate the galvanometer current. And by applying this formula, VTH is equal to 0.002, VTH is equal to 0.002, and RD is the internal resistance of the galvanometer, and that is Thevenin's resistance 880.04 is equal to 2.04 microampere. And it is asking about deflection of the galvanometer. So our formula is saying that deflection of the galvanometer is equal to sensitivity into current. So our sensitivity is given in the question. Let's see here. Here is the sensitivity. I think screen is covered here. So this is sensitivity 10 ohm, 10 millimeter per microampere is the sensitivity here is given in the fourth line. See properly, in the fourth line it is given 10 millimeter per microampere is the sensitivity of the galvanometer. So we have to calculate the deflection of the galvanometer. The deflection of the galvanometer is equal to sensitivity into current. Remember that important formula. So sensitivity into current, sensitivity 10 millimeter per microampere into our current across the galvanometer is 2.04. Here is not equal, it is multiplication. Therefore we will get the 20.4 millimeter. So our problem is complete. Thank you for watching, my friend.